All right, so today we're going to be talking about insecure deserialization. So let's just jump into it first by talking about what serialization is. To put it simply, it's the process of converting some kind of complex data into a simpler format that you send as a stream of bytes. This is typically easier to write into memory or files or databases just because you're translating a complex object to just a stream of bytes. So it might be a little bit more optimal for some of those scenarios where you're bound by some other constraint. And after you serialize this data, in order to use it with some program, you're going to need to deserialize it back into its original state, which forms a replica of that original object. So the picture that I've got up here is just something I drew, and the easiest way for me to understand why you might do this, especially if you're not a programmer, is, because this takes a lot of pieces from object-oriented programming, which is why you see it a lot in Java. But let's imagine you have a video game and you have an object called player state that determines or saves the state of a player when they leave a game server, right? It saves their X, Y, and Z position. It saves their crosshair position relative to where they were standing, something like that. It makes more sense to store that in a byte stream on the game server than it would to, store it as a full object. And then you would just have a, serialization operation where you turn that data from the player's game client into something that's stored on the server. And then you take that data when the player rejoins the server, deserialize it, and then boom, you're able to read the player state just as it was earlier. This is just the easiest explanation I have for it, but most of the time you'll see this in Java and PHP, but then again, the word for serialization changes depending on your programming language. Like in Rust, it's called marshalling, and in Python, it's typically called pickling, which can be confusing if you're looking up a deserialization exploit and you see a bunch of articles about pickles. So just something to keep in mind when you're doing your own research. But we'll talk about what can actually make this insecure. And most of the time, it's just if an attacker or us, in this scenario, are able to control some kind of data that's going to be deserialized, that kind of by itself can make it insecure, so long as you're able to get some malicious logic to be executed or get some kind of malicious action to occur. So I want to first just go over what an object looks like. So let's say that you've got some serialized data here. So the object is a username and a variable on whether or not we're logged in. It would be, okay, here's the object. It's 4 characters long. It's the user object. It contains 2 attributes, a 4-character string name, which is defined by this 4-character, value, Gabe. And the second attribute is a 10-character long, the second attribute's title is 10 characters long, is logged in, and it's defined by a Boolean. In this case, it's set to true. So this is like what a typical PHP serialized object might look like. And it might contain stuff like this. It might contain different data. It really just depends on the context in which this data is being used. Java serialization format and a lot of serialization format is usually like base 64 encoded. So Burp Suite is nice because if you hover over, some base 64 encoded data, it'll decode it for you in the sidebar, which is really convenient. But that's, most of what this will look like. The reason this is insecure is because if we can control our name, or if we can control this data in transit by capturing it with a proxy, we could potentially do some devious things. And the first couple I'm going to talk about are just, manipulating these, right? So let's say that we've got a website that logs you in doing something like this. So when you log into the application, you submit a username, and access token might be, like a hash of your password, or a hashed and salted version of your password. So you don't know how it's being salted. It's really hard to determine, et cetera, et cetera. So let's say you want to take over someone else's account. Well, this thing that I use right here specifically takes advantage of something in PHP's serialization, which is PHP will always try to fix the data type if it believes it to be wrong, which is an oversimplification. But basically, if I had a string and I was comparing it to an integer with like the equals operator or the double equals operator, if the string started with the number 5, it would evaluate to true. If it compares to if you're comparing the integer 5 and the string 5 something, if you're comparing an integer 0 to a string, it'll always resolve as true because it, takes precedence as an integer. And 0 would evaluate to true for everything because every single string would not contain nothing, or would contain the nothing. So in this case, if you know somebody's username, you might be able to take over their account, because when this 0 gets parsed in, it compares it to a hash salted string and says, okay, well, this results true, therefore, you're able to log in. You also might be able to abuse session functionality or the application's functionality itself. For example, this right here, it has a link to your profile picture on some directory on the web server, and you might think, okay, well, maybe I could do LFI from this. You also might be able to delete data if you delete your account and deletes whatever's stored here. And again, this is just changing the, in this example here, you might want to change the data itself. In this, you might actually change the data type of one of these attributes that's included in the object. And the next thing we're going to talk about is, object injection and subsequent things that could happen after object injection. So the primer for this is magic methods. These are methods that are contained automatically by programming languages. And a good example would be, let's say you're writing a Python program and you use the plus operator. The add method is a magic method that would actually perform that, mathematical operation of adding those two things together. And you'll usually see this with, other examples in Python are init, or in PHP, there's wake up. There's a bunch of different ones, but this is handy for attackers because if we're able to inject an object that has attributes from, or has these magic methods in that class, then we might be able to use those magic methods to perform more things. A good example is kind of in this flowchart that I borrowed, where if your object is in a class that has these, magic methods or whatever, if you're able to inject an object and call wake up or destruct, those would be, depending on the application environment, pretty risky things. Now, the tricky part is that this is really, that kind of strategy of specifically picking out your magic methods is easiest when you have source code access, and you're not always going to have source code access. So the solution to that, or, sort of solution to that, is gadget chaining, or utilizing gadget chains. And a gadget in this context is some kind of snippet of code that helps us achieve some certain action. So, even though we only control some input, we can still make our payloads in a way that takes advantage of multiple sensitive gadgets in an application. And, because identifying these gadgets even is difficult, there's tools like Why So Serial for Java, which will help you generate your payloads, or PHP GGC is another one that you could use. In the lab that we'll do next, there's a specific script that just generates payloads for you by chaining a few things together. But to summarize, gadget chaining is really the biggest way that you'll actually be pulling off these exploits. But that being said, let's just jump into the lab here. We're going to talk about NodeJS deserialization. It's a really specific bit that lets us do some code execution. And then we'll jump back here and talk about prevention. All right, so I've got the machine Celestial pulled up on Hack the Box here, and I'm just running a quick port scan, even though I've walked through it before and it's not super vital, but you run your port scan, you see, okay, 3000 HTTP, and you see that it's using Node.js Express framework. So when we actually do our research, it's going to have to be a little bit different, but basically if you go to the site, it'll behave like this. 2 + 2 is 22. There's not really much else to do with this site, and you can kind of tell this Hack the Box machine is a bit older, but I didn't want to give us a super long set of things to do with Why So Serial and gadget chaining, so this is a pretty straightforward example. The only real data or info you have to work off on this site is a cookie called profile, and if you take this and you, it might be hard to tell, but this is base 64 encoded, so if you were to bring this over to CyberChef or Burp Suite, you could base 64 decode it and find something like this. And first what we'll do is just test and see if we're able to make changes to this and get it to work. So I'm just going to delete this. And then we're going to instead encode this, and we're going to change, I mean, obviously, right, the number 2 seems to have some significance here. I mean, our username is here. Let's see if that actually works. I haven't tried that, but we'll change this to like 11 or something, or let's do 12, just so it doesn't look repeated, because it takes 2 and 2 and gives us 22. We don't want it to be confusing. But now that we have this, I'm just going to throw this in the cookie here. Save it. It tends to do this if we're too fast. Let me try this again. We save this. What if I set it manually like that? There we go. So you can see how when we manipulate that serialized data in the form of, this, cookie, it, the application does process that. We know that it's deserializing it at some point and using that logic in the program. So what can we do with that? Well, if you Google Node.js, and I'll just show you. If you Google Node.js deserialization, this first link from 2017 is literally like the only reference that you're ever going to need for this, I think, at least in what I found. But it goes into great detail about how you can use immediately invoked function expressions to pass a new object. So this is object injection. And without getting too much into the weeds, we talked about building the payload, how you can use it to execute commands. In this case, ls is the one that's used. And then there's a Python script that we can download. This is from 2017, so Python 2 is what you'll need to use. And you can see it just generates a payload for us depending on the input. So we can go ahead and make one. I've got this set to my IP. Let me just do NC. So I'm listening on port 1337. I'll create this, and then we'll just need to base 64 encode it so that the website doesn't get mad. So let's do that. And this is quite long, but we can probably, I'll try to just replace this and hopefully it doesn't throw a fit. It just might though. Let's make a new one. Save this. It gives us an error. Okay. Unexpected token. That's interesting. This did not happen the first time I did this. But okay, so I forgot one important detail, and it's that we actually need to change this a little bit before we encode it. So we need to include these, what are they called? These IIFE parts before and after. So this RCE function part, I believe. Let me double check. It might be at the very bottom of this. Yeah, here we go. So let's just add those to the beginning and end, because it needs to be in the right format. Let's see. That's a double there. Let's see if this works. Let's just trash this cookie and refresh, and then we'll just make a new one here. Okay, different error, but this time you can see our listener gets connected. I could do like ls, who am I? And we get a shell. This is the user foothold for this machine. So that's an example of Node.js deserialization that we can use to inject an object. And then by injecting that object, we're able to call, let me see if I can find the actual function name here. Eval, but in this case, it lets us execute system commands. So there's a good example. We'll go ahead and jump back and then wrap up. Typically, these things are caused by too much trust in user input, either in the fact that the user input is, not being sanitized, or, is assumed to be trusted in its deserialized state, which we know to be false. It also opens the attack surface because when you are, when you have a ton of objects and classes that all utilize magic methods and things like that, and there's a bunch of different gadgets on your application, as long as I can find one deserialization vulnerability, it greatly opens the attack surface for me, which is why, these kind of vulnerabilities are typically labeled as like a high or critical, depending on, what your proof of concept code you give is capable of doing. And if you're trying to prevent this, really avoid deserialization of any kind of user inputs. And if for some reason that's not an option, right, make sure you're validating that data based off of some kind of expected result. If you know that there's only supposed to be one object in the response, do a length check. If you know that there's only supposed to be certain types of data in there, just validate and check that data that's being passed before you deserialize it and as you get it, so that you can actually, make sure that nothing funny is going on, and then return an error message that reveals no information to the attacker. And then if, that's also the case, you could implement class-specific deserialization methods so that they're not able to implement, attributes from other classes or create an object from another class. But that's all we've got to go over today, and I'll catch you in the next one. Thanks for coming in.